For section 2.4, we're going to be working with more identities. In 2.4 and 2.5, we're going to expand those options of the ways we can write and rewrite some of our trig functions. Now, I know some of you are probably getting anxious about this, and rightly so. There's a lot of these things. If you flip to the back of your textbook, there's a kind of a cardstock-like back page there. And if you flip it, you have to, I think, flip to the inside of that. There's a page there that looks like this. Okay, the stuff at the top left has the things that we've worked with, and of course your unit circle is there. If you slide down the left, we have talked reciprocal identities. We know how to write things in sines and cosines, and we've worked Pythagorean identities. We have talked cofunction identities, even though we use them less often. And the truth is, after today, we could prove those if we'd like. There might be some in your exercises where that is requested of you. Which functions are even and odd? And today we're going to work with these sum and difference formulas in section 2.4. Those are the ones I'm going to zoom in on. Now, what I was kind of keeping to myself until after spring break is that I was going to have a photocopy of this sheet for you here, for you to use during your test, because while yes, I think there's a few of these that are worth committing to memory, like the Pythagorean identities. There's so many that it's more important that you can use them and use them the right way when presented with a problem where you need them than that you memorize this entire page. There's a handful of these. I know all of the left column by heart. I know the right column down to here. These guys, I couldn't tell you if I had to off the top of my head, but here and the left column from calculus, from trigonometry, use them often enough that I really don't have to look back to this sheet to see what they are. But again, do I expect you to be there? No. So that's a very long 2-minute explanation of you can use these, and of course now that you're at home, I can't see what you are or are not using, but this is what I was going to allow this page here on your quizzes and tests from here on out. So we'll start working our way down through, and again, finishing that bottom left column there. We're going to work with the sum and difference formulas today. When you see a formula like this, there are really 6 formulas and not 3 written here. But the author, to save space, is going to write it this way. Okay, please understand that the top symbol here, if I have the sign of u plus v, that I'm going to be using the top symbol here, meaning the plus sign. Okay. If I wanted the sign of u minus v, that's the bottom symbol, that would be the bottom symbol here. Okay. Same thing, I still have the green in my hand. If I have cosine u minus v, the bottom symbol there is a plus sign. Okay. And the plus sign up here goes with the minus sign over there. It would be the same thing with the tangents down below. So what that allows us to do is practice, 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 practice. Okay. If I have something like the sine of 135 degrees minus 30 degrees. Okay. Now, of course, I could write that as sine of 105 degrees on my paper, but the author is helping us out and saying, hey, look, I can write it as the difference of these 2 angles, and I know things about these angles. 135 has a 45-degree reference angle, and 30 is 30. If we use the top formula for the sines, I mean, we look at the sine, and it's the u minus v, so it's the green symbols there. That says we could expand this and rewrite it by saying we have sine of 135 degrees times cosine of 30 degrees. Okay. Sine of u, cosine v. Then I'm going to subtract cosine of 135 degrees times sine of 30 degrees. Sine u cosine v minus cosine u sine v. Here then we do the arithmetic. The sine of 45 degrees is square root of 2 over 2. When I'm in the second quadrant, that stays positive. Cosine of 30 degrees is square root of 3 over 2. First quadrant, everything is positive. Cosine of a 45-degree reference angle is square root of 2 over 2. And since I'm in the second quadrant, the cosine is negative there. And sine of 30 degrees is 1/2. First quadrant, always positive. If we put these pieces together, we have square root of 6 over 4. My two negatives make that a positive, square root of 2 over 4. Okay, they have a common denominator. If they didn't, I would put them over 1. Most of them will, though. All of them should in that step. Maybe I want to find the cosine of pi over 4 plus pi over 3. Sorry, that's kind of wonky looking. Our cosine relationship is the middle of those three up there. Between the two, the blue and the green. If I have a plus sign in between, I'm going to use the top symbol. So if I have cosine u plus v, then I have cosine u cosine v. A plus sign in between them on the left side means I'm going to put a minus sign in between them here. Sine u sine v. So cosine pi over 4 is square root of 2 over 2. Cosine of pi over 3 is 1/2. Okay, both of those are first quadrant. All of these are first quadrant, so everything will be positive. Sine of pi over 4 is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. Okay, I'm going to do this all in one step here so I don't have to slide my slide. But on the top, on the left fraction, I have square root of 2. Top of the right fraction, I have minus square root of 6. And all of those things are over 4 again. Okay, this would be the exact value of the cosine of, and if we found that common denominator there, that would be cosine of 7 pi over 12, which if I just asked you at your desk, hey, find me the cosine of 7 pi over 12, that's not one of our special triangles, which means I couldn't have to spit out that answer. But writing it as a sum or a difference of two angles that I do know, okay, that helps me out immensely. So, at your desk, at home, please, and the author again helps us out here. It says, hey, I'm going to let you know that negative pi over 12 is the same thing as pi over 6 minus pi over 4. And so I would really like it very much if you would find me sine of negative pi over 12. Okay. Or, that's code for find me sine of pi over 6 minus pi over 4. Go ahead and pause the video. Use the appropriate formula up there. Find me the exact value of that, please. All right, so using the difference formula from the top, we have sine of the first, cosine of the second, minus cosine of the first, sine of the second. Again, all things here are in the first quadrant, so everything here will be positive. And if I can write and talk at the same time, I'm going to go from right to left here and say we're going to get square root of 2 minus square root of 6 all over 4. Okay, same thing that we got a minute ago. Which again, remember that I mentioned this is 7 pi over 12. Okay, second quadrant, and a reference angle of 5 pi over 12. Okay, negative pi over 12 would be fourth quadrant. 3. I don't know, I just crisscrossed my wires there. But but it is possible to have different angles that are evaluated, and the sine and cosine are the same. Sine of one is equal to the cosine of the other. Yes. Okay, I have a minus pi over 12. It's a cofunction thing. 7 pi over 12 and minus pi over 12. Again, my wires got crossed there. Okay, I want you to try one more. My video is getting long, so I want you to try one with the tangent since we haven't done one yet. Pause it, work it as far as you can. When you turn it on, the whole answer will be there. I'm not going to talk through it. I'm just going to have it written down. So pause it, try to give that one a shot, simplify it completely, and when you turn it back on, poof, it'll all be there. Okay, here we are. I did this two different ways. Here is one approach. Here is a shorter approach. The top one is what I did in college algebra with my class. The bottom one is where your maturity should be working towards. Now that we're at this level, sorry, trying to make things stop flashing. Go away, go away. But don't forget, we need to rationalize the denominator. So pause this, look through the steps, see what you think about it. It'll hold